Hi, everyone. Thank you for showing up again for your learning. Let's take a look at how we can use the Pythagorean theorem to solve for the length of unknown sides of right angle triangles, and also how we can solve for unknown angles using the properties of triangles. All right, so I've got some triangles prepared for us over here. They're sparkly triangles. Let's say we want to find x. All right, I want to recognize that these two are the legs of the triangle, and this is the hypotenuse. So if I write this out, I know that x squared will be equal to this one squared, 9 squared, plus this one squared, 1, 2 squared. Okay, so now let's solve this. Let's put me out of the way up inside that triangle, sure. And now, if I want to solve that, I need to evaluate both sides. So x squared equals 81 plus 12 squared is 144. 9 times 9, 12 times 12. Put these two together and you will get, um, well, they add together to make 225. Check on your calculator. All right. And I know that that's equal to x squared. All right. One last thing I need to do to solve both sides, and it's my only sort of inverse operation that I'm going to do, tricky algebra, is I take the square root to get rid of this square. Taking the square root of a square just gives you the thing. So that will tell me x is equal to, do this on your calculator, and you'll find out that it's 15. So there's the answer. And so this is x equals 15. So if this is 9, this is 12, and that's 15. We should also look and see, does that look reasonable? We want to imagine a side length 9, a side length 12, and then across them a side length 15. It looks reasonable because if I line them up flat, like this was 9 out that way, that'd be 9 plus 12 is 21. And 15 is certainly shorter than 21, but longer than 12. So that makes sense. And before you do this question, you can kind of guess as well. Make sure that your guess lines up, and then you'll train your guessing ability. What about up here, where I want to find this unknown, and it's on the bottom? Okay. Sorry, it's not the hypotenuse, when the hypotenuse is not the unknown. So in that case, I do the same thing, but I make sure that the hypotenuse is alone on the equal side. Because when I have a triangle here that's a right angle triangle, this is A, B, and C, then A squared would be equal to B squared plus C squared. Okay? Because the hypotenuse is always the one that's alone, and then you take the square of the two legs, add them together, that's the square of the hypotenuse. So in this case, 26 squared is equal to y squared plus 10 squared. Okay, and 26 times 26. Well, we could use a multiplication trick to do that. We could say this is 20 plus 6 multiplied by 20 plus 6. And you could start to do this in your head, but because I'm talking, I can't do it in my head. And then you do first times first, which is 400 plus 120 twice. That's 20 times 6 plus 20 times 6, and then plus 36, okay? That's 6 times 6. Okay, so I just used my FOIL rule. 400, 120, 120, 36, and that gives me 676 is 26 squared. That looks reasonable. So this is 676 equals y squared plus 100. 10 squared is 100. Okay. Now we subtract 100 from both sides, and we get 576 is equal to y squared. And then we're going to take the square root of both sides. Notice we had this one extra inverse operation we had to do if we were setting up the equation this way. Okay, the square root of 576 is going to be equal to y. And the square root of 576, well, that's 24. 24 equals y. Okay, cool. All right, how do I know? Well, let's do it on a calculator. Okay, I'm going to type in the square root of 576 equals 24. Okay. So, I should have told you to make a guess first. I'm forgetting to make a guess each time because I know the answers before I do them because I created the questions. Okay, so now another thing I want to mention about the Pythagorean theorem is if I didn't tell you that they were right angled, like that was not information that was given, but you were told that the side lengths of a triangle were 26, 10, and 24. If you can prove that they do this, that they follow the Pythagorean theorem, then you've proven that it's right angled. Okay, so that's another way that it works backwards as well. It works as a proof. If you need to prove that something is a 90-degree angle, you can use Pythagorean theorem to do that. All right, now one last thing to talk about. I'm going to remove these side lengths because we're not going to work with those, and I'm just going to work with some angles. If I know that this is angle 90 degrees, and let's say I told you that this angle over here was 23 degrees, okay? And I said, find me this over here, find me theta. Theta is a Greek letter, so it might become a COVID variant at some point, but that would be sad. Okay, theta over here, and if we wanted to find angle theta, well, we have to use the properties of a triangle. We know that the sum of the interior angles of a triangle is always equal to 180 degrees. If I add this angle to that angle to that angle, I will get 180. So I can create an equation. 180 equals 23 plus 90 degrees, that's 90, plus theta. Okay, now I add them all together. This is 180 equals 113. Okay, that's 23 plus 90 plus theta. Now, it's break time. Subtract 113 from both sides, and that will give me the value of theta. Okay, because this makes it 0, so now I have this is equal to theta. 180 minus 113 gives me 67 degrees. So this one is 67 degrees. Okay, so that's how you solve for unknown angles. Now, what if there's not a 90-degree angle in there? Well, let's create a new triangle, let's say. Okay, so here we go. We're going to create a fancy a non-90-degree triangle. Let's look like this, this, and this. Okay, there we go. Now, here we go. This one we'll call, looks kind of like 90 degrees, doesn't it? Let's say it's 80 degrees. Okay, this one down here, 35 degrees. Okay, and then I say, find me angle beta. All right, then I just set up the same equation. 180 is equal to 80 plus 35 plus beta. Okay, now 180 equals, add these together, that's 115 plus beta. And now we're going to subtract 115 from both sides. Okay, 180 minus 115, 65, okay, equals beta. So now we've solved for that angle, 65 degrees. Okay. To be honest, this one is a little more than 35. This one is a lot less than 65. This is closer to 90 than it is to 80. But I already said I'm sorry for my poor diagramming skills, so maybe I need to work on that. All right, so thank you for showing up for your learning for this brief lesson on solving for unknown angles and exploiting Pythagorean's theorem to either prove a triangle is right angled or to solve for unknown sides. Any questions? Send me an email or hit me up in the chat.